Hi everyone, welcome for joining. We will start in 1 minute at the top of the hour, so please stay tuned. Thank you very much. Okay, it's now 6 o'clock. Thank you very much for everyone joining. So this is the first time we are trying out this online meeting together with the .NET user group Zurich. I hope you can all see my screen. This is really a joint venture collaboration thing. We decided to cancel the physical meeting, and I think under the light of the latest Swiss Federal Council announcement, I think we can all say that this totally makes sense. And from a user group perspective, from the .NET user group Central Switzerland, we will definitely stick to the virtual only for a while, or potentially even not do some presentations or only if necessary. We still have to decide what we can do. But anyway, for tonight, I'm sharing here the slides that Jose and I collaborated on, so that he will also present to the .NET user group Zurich. But we don't want to waste a lot of your time because you're all here to hear Szymon. So let's get started. So Szymon is reachable on Twitter under @Szymon Pobiega. So please follow him on Twitter. Should you have any questions, by the way, there is a Q&A section. You can always ask questions in the Q&A section. And like any other user group, feel free to do it during the presentation, and we will then interrupt gently Szymon and ask him the question, and then he can answer those. So it should be, even though it's online, it should be a collaborative kind of thing as much as we can, of course, because it's an online event. Okay, so from our perspective for the .NET User Group Central Switzerland, it's important to mention our sponsors because they make everything possible. So we have BBB Software Services, Mattis and Chaitlin, and BBT Software, and also Fro Limited Liable Company, one of our regular user group members. So thank you very much for helping us to cover the travel costs and accommodation for speakers. Without the sponsors, it wouldn't be possible to host those events, not even the online ones. Now I transition over to Jose.
So thanks, Daniel. Thanks, Urs, for the opportunity to celebrate this. And as you said, it will probably not be the last we are doing things together online until this situation calms down. That said, we want to thank you, especially today, Particular Software. They gave us today for using their license of Zoom, which is an enterprise license, so we can have up to 500 persons. So I think we can try to promote these kind of events even a lot more than we are today. As a gold sponsors, we have to highlight Offering Solution Software and ForTexture as a gold sponsors. As location sponsors, thanks to Impact Hub, Zurich, and Stanford Group, and also thanks to our partners, Azure User Group, .NET Central, of course, who else? .NET Day Switzerland and Swiss Angular. Can you go next? Cool. Yep, better. Yeah. So who is .NET User Group? It's organized from developers for developers with the goal of shared knowledge, create excitement about technology, networking included, beer and pizza, well, not today. And well, well, we hope we can get back to this in short. Can you go next? Yep. Who is behind this organization in a Zurich .NET User Group? It's Mark Muller. There is Fabian Gosbrink. He could not be here today. Laurent Bunion, Nigel Finlater, and Pavel Nivolny. I think he's here today. Hi, Pavel. And then it's me, Jose. Thanks everybody for organizing and helping on organizing this. And then what can you do if you're there? You can follow us on .NET Zurich on Twitter, join our meetup group. Also today, I would have to say .NET Central as well. And tell your peers, help us grow and propose also new content and speakers. You can find us on .NET-Zurich.ch. And if you want to tweet about that, you can use .NET Zurich as a hashtag. And also we are looking for something that we are copying or trying to copy from our friends from .NET Central. They are doing short lectures sometimes. I don't know how you get them, Daniel, but we have been looking for them for a while. But
yeah, it's difficult.
Yep, I know.
But that shouldn't prevent anyone from
Yes,
from joining.
exactly. So if you have a topic you would like to share, feel free, even it's 10, 15 minutes, 20 minutes, 30 minutes. Yeah, I think it would be nice to share. Next.
Okay.
And that's it for us. I think now we can already go and present the speaker. Thank you for being here today, and see you next time.
Okay, Szymon, over to you.
If you don't like me moving in the background, please focus on the presentation, not on me. Okay, so thanks for inviting me. I was really looking forward to be in Switzerland this week, but yeah, unfortunately the circumstances didn't allow me to get there. So really, it's really cool that we were able to set up this online version, and I'm really happy that so many of you joined. So bear with me for the next hour or so while we'll be talking about tactical domain-driven design patterns for a distributed system. And I know that's a very lengthy title. It barely fits my screen, so I would like to start by unpacking this title a bit. Why doesn't my clicker? Okay. First, tactical. Tactical means it's something that you can use in a normal day-to-day job. You don't need to get a permission from an enterprise architect or a business person to actually use the content that I will be talking about today. So it's smaller scale than huge enterprise kind of architecture. And then domain-driven design is something that I have background in. It's a software methodology that focuses on building software aligned with business. Then the patterns, because I don't think there are many best practices in software. I'd like to focus on patterns, which means those are solutions to the concrete problems within the concrete context. So outside of that context, those things that I'm going to present probably don't make much sense. Inside those contexts, they help us to resolve certain forces in a positive way, positive to the overall design of the software. And the last thing, for a distributed system. So if you are happy in your place building non-distributed systems the old way, stay there, be happy. If you're forced to do distributed systems, for example, in the cloud, that will be some information for you. I hope that you will enjoy. My background is in domain-driven design, as I mentioned. I started being interested in domain-driven design some 10 years ago when it was still a niche idea. Then I focused on event sourcing because everybody was doing event sourcing at that time. And the main problem event sourcing seemed to solve is how to register users in a system in a secure as compliant way. I guess that was the main achievement. And
Szymon, quick question.
Yeah, sure.
So it seems like that your microphone quality significantly dropped from when we tested it to now. I don't know what the reason is, but
okay, I can try to switch to regular audio.
Do you mind quickly give it a try? So because
yep.
That would be really nice. I mean, it is sustainable, but it's
okay.
Definitely could be better.
Okay, cool. You might hear my kids in the background all this time, but hopefully we'll be fine. So I would like to tell you a story, and because I watched one presentation by Daniel about Swiss chocolate that inspired me, and since then every presentation that I'm doing is sort of themed around pierogi, which is kind of Polish national dish. So this will be a story also about pierogi. And usually I start my presentation with a picture of this guy, the architect. And the reason for it is that it's easy to make fun of architects. And I can actually make fun of architects and mock them without being sorry or feeling guilty, because I used to have architect as my job title. So nobody can claim that I'm making fun of other people. When I'm mocking architects, I'm making fun of myself. So that's what usually I do. But this time I wanted to switch my focus and experiment with a different type of organization of our virtual software team. Instead of having one architect, a white male in his 50s with a gray beard, we will have more diverse community of architects or software engineers. The ponies, there's 5 of them, and they have really good background in IT and very diverse background, meaning that each of them, those ponies, will bring valuable insight to our story about pierogi. So if you want to build a startup and sell pierogi worldwide and deliver them to people's homes, which is essential, especially during the time of pandemic, because people should not leave their homes. We should have a system that delivers pierogi to their places without them having to talk to other people or meet other people and spread the disease. You need first a shopping cart. And then the shopping cart implementation and design was handed over to Pinkie Pie the architect. So Pinkie Pie started designing the architecture the way she was used to design the architecture. She started with a user interface that is a single page application, so very nice UI. You click on the screen, and instead of refreshing the whole page, there goes a HTTP request to some sort of API hosted on a web server. And that web server doesn't do anything, actually. It packs that web request into a message and puts that message into a queue. Why? Well, Pinkie Pie had some experience in big scale system, and she knew that in that kind of e-commerce systems, there are spikes in load. There are times during the day or during, depending on the month, that the load is significantly higher than the average. And to handle those spikes, you need a queue to level the load so that the processing component that is behind the queue, the shopping cart component, can just take messages from the queue one at a time, despite that the messages might be backing up in the queue during times of peak. And then the shopping cart processes those messages, and processing those messages involves changing data in a database. And then UI periodically asks the API about the new state of the database. The idea was nice, but the POC was built. But during the first testing of feasibility of the solution, it was discovered that the latency is too high. So people click on the UI and they don't see the results immediately. So they designed a mitigation solution to that. Instead of just refreshing the view using a web API, they decided to use WebSockets for SignalR. So that shopping cart component, it not only put data into the database, but it also put some message, reply message, or event message into another queue. That queue was consumed by the web server, and the messages were turned into WebSockets packets that were sent to the user interface. So the round trip, or the time between clicking on the interface and seeing the results, was shortened dramatically, but it wasn't enough to satisfy the user experience experts around in that company. Still, we could click on the UI and wait a couple of seconds until the messages went through one queue and the other queue to actually, for the user to see the results of them clicking. And it created confusion because you can click here and there, and there would be more than one operation at the time being processed. And then the results of those operations could come out of order. So the users were really confused. We wanted something better. And something better was actually visualizing the progress of those operations that the users were doing. So when you click on the UI to do some action, you wouldn't just send a web request immediately. You would store the desired state in a local database in a web browser, and then send a web request. And then when the operation is confirmed, the operation is processed, we actually can mark this operation as done. So at any given point in time, the user would have part of the screen as a site that would show pending operations, and that would give the user indication where in the flow they are. If their operation to add things to the basket has been completed, or maybe stalled, or is waiting for something. And that was something that they thought that it's okay. It was very, very complex, and that was one of the concerns that our Pony architects had. And well, one of them, the shy one, Fluttershy, decided to actually speak up and question the design. And first, she asked a very valuable question about the value of the web server in that design. See, what the web server here is in the center, so it suggests that it's important. But if you take this design or this picture as a picture of a logical architecture of a system, the web server isn't really doing anything. There is no user code or solution code deployed to the web server. It just takes a HTTP message and puts it into a queued message, and then the other way around, it takes a message from the queue and turns it into a WebSockets communication. So it's not really a logical architecture part. It's very important piece of infrastructure, but it's only infrastructure. So if we take it out of the picture, we can see clearly what's going on in the diagram. And we'll see even more clearly if we slightly reshuffle the components here. So here's what's happening. We have the UI. The UI stores its own local data in a database, sends out the HTTP requests. That request is put to the queue. Shopping cart processes that request, modifies the data, replies back, and that reply is correlated somehow with the data on the UI side of things. And then again comes Fluttershy and says, well, it looks like multi-primary replication, doesn't it? And well, Fluttershy has some background in the databases, and that means not only that she can write a select star, but she really understands how databases work. So she redrew that diagram into something like this. We have a shopping cart in the center and two instances of that UI, two browsers. And here you can clearly see what is happening. Those two browsers two of them send some requests for modification of the data, and they modify the local data. Then the shopping cart component, or whatever the business component we have, needs to reconcile those requests and stores the state in its own database. And that state gets broadcasted through WebSockets to the clients. And it might happen if the changes that those two UIs submitted are conflicting, it might happen that one of the changes is accepted while the other is rejected, for example, because there is no more pierogi with meat available. And now we have a conflict because the local database says something happened, while the central database that the shopping cart component uses says it didn't happen. So it's basically the same problem as with any multi-primary replication has, which version wins. Well, here, most of the time, the central version would win or should win, but still it creates confusion in the mind of the user that something was supposed to be done, but it's not done, or so the state was supposed to be like that, and now it's changed because, well, something changed in the meantime. So Fluttershy, she proposed to change the design and to make it simpler. She's really good in making things simple. And in her mind, that's all that is required to implement that shopping cart solution. So there is a UI, and then the UI sends HTTP requests to a shopping cart. Shopping cart stores the data and, well, returns HTTP response. Good old HTTP, all synchronous. Because it's synchronous, the UI is, well, maybe it's not as responsive, but at least it's simpler, both to implement and to understand by the users. The user clicks a button and something happens. Even if the screen blinks for a second, it's still a feedback that something is going on. So it's like HTTP the old days. But apparently when they started exploring the design when she started exploring that design with the other ponies, it's actually, it appeared that it's not that simple. So yeah, shopping cart is one part of the system, or the one part of the shopping cart is really synchronous, but there is some batch job that needs to be done, some offline processing. You can imagine, you can think about it like this. There is so much stuff you can put into a SQL, a statement that you are executing as part of your web request. You can't add more SQL statements to it and process the whole business transaction there, because sometimes fulfilling an order takes 30 minutes. And then you don't want to have a 30-minute long transaction on a database, because that would kill a database. So whenever there is a period when there's inactivity that is inherent in the business process, you don't want to keep the transaction open. So we just store the data, and then something will wake up, like a batch job, will figure out what pieces of information needs to be changed, and will apply the business logic to those pieces of information. So in this example, the batch job would look for shopping carts in certain state and execute that processing. So yeah, that's moderately complicated, still simpler than the initial solution by Pinkie Pie. But apparently it's not that simple. So shopping cart is only one of the components they envisioned. There will be a shipping component and a billing component and many more components in that distributed architecture. So how do I get my data from the shopping cart to those components further down the line? Well, the first thing that Fluttershy figure out is, well, you have a database and another database, we can do replication. Well, the other ponies were not really happy about database replication, or even any sort of moving data between one database and another database, just using pure database technology. That was a no-no for the other ponies. So, well, that was another proposal. If we can't just move the data between the databases, let's just call HTTP web service, right? It's sort of the design, like Netflix kind of scale agnostic design, where you have web services, all the things, and one API calls another API that calls another API. Only the problem here was that those APIs calling them the other APIs were not requesting data. They were actually about to modify the data. So the shopping cart component, as part of processing its own HTTP request, needed to modify the data in its own database and send some data to modify stuff in the shipping database. Well, obviously, since WS star is dead, you cannot have a distributed transaction through HTTP request. So you cannot do a local change in a database and the change in a remote database through any sort of web service technology available right now. So that's not really possible. You cannot do that atomically. Either way, you would lose data. So the only solution to that problem that the ponies could figure out at that time was to use a batch job, another batch job, to move the data from one database to the other. So the shopping cart would store its own data, but it would also store information, a piece of information like a message that needs to be transferred to the shipping component. And there will be a batch job that wakes up every minute and looks for that request to change data in shipping. It would deserialize that request out of the database, pack it into HTTP envelope, and send over to an endpoint, HTTP endpoint in the shipping component that would store that data. So that was a pattern. No data loss, because shopping cart stores both data and the outgoing message, and the batch job can be configured in such a way that whenever it fails to send the HTTP requests, it can retry sending those HTTP requests until it gets confirmation from shipping that the data actually went through to the other side. And now, slightly belated to the meeting, Rainbow Dash comes in. She's always in a hurry, flying somewhere. And she just opens the door and said, "Ooh, so you decided to build a poor ponies queue, right?" And the other ponies were like, "What? What do you mean?" "Oh, well," she circled around this part of the system and said, "Well, that is a queue by definition. You store a message, like the shopping cart would store a request to change data in shipping, that's a message. And then you would have a process that takes that message from one place, one persistent store, transfer it over somewhere else, and store it in another persistent store. That's the same thing as MSMQ, the queues built into Windows do, or another queuing system. So it's poor man's queue, poor pony's queue, actually. Well, at first they were devastated, but then the Twilight Sparkle, she is the smart one, she had an idea, as always. She decided that she will redraw the diagram again, using ideas both from her colleagues. So she kept the simple UI design that was created by Fluttershy. So we have a UI that is fairly simple, synchronous application. You click a button, there is a HTTP request to a shopping cart and an HTTP response. No WebSockets, no stuff like that. And shopping cart stores data in its database. But in the same transaction that it stores the data in its database, it sends a message to change the data in shipping. And that message is not moved magically through some sort of batch job-based system, but it's actually put on a proper queue, and the shipping component can take that message from the queue and store it in a database. So what we'll see here is that the left side of the screen, it's synchronous. It's really simple to build because synchronous UIs are simple to build. Users get really fast feedback about what they are doing. So the user puts an item into the queue, and the latency to get feedback that the item got into the put item into the shopping cart, and the feedback that the user gets about the item being in the shopping cart is really fast. And that's what we want to optimize here. We want to optimize for latency, not necessarily for throughput. In an async system, yes, I can handle really big load by leveling that load in a queue, but then the user experience is really terrible because users need to wait for feedback for a long time. Here, I click, I get a feedback. Either I managed to get that item into a shopping cart or not. And then I publish or send a message or publish a message to a queue. And then the shipping component, it can process that message asynchronously. For example, that message might be the user submitted the order. So as long as the user is playing with the order, adding pierogi, removing pierogi, that stays in a shopping cart and stays in the synchronous part of the system. And then when a user is ready and actually says, okay, I want to submit it, and from now on, I don't care if that thing is processed in 5 minutes or 6 minutes or 15 minutes, if it takes that much time, it's on you, on the system, to process that order. So the user clicks submit, and that submit means that the shopping cart component sends the message to the shipping, billing, and all the components further down the line that communicate asynchronously. So this design with a sync-async boundary allows our system to benefit from both all the benefits that are associated with synchronous communication on the user-facing side, as well as all the benefits that are related to asynchronous communication at the backend, meaning that we can level the load, we can scale easier the asynchronous system, and generally the asynchronous systems are easier to reason about if they are based on the queues, if they modify a lot of data. So sync-async boundary, that's the first pattern. We were able to salvage while talking to customers, and it's useful when you're designing a system that has a backend part that is about processing some orders or long-running processes, and a synchronous part that is about interacting with the users. So here's the details that Twilight Sparkle proposed. This is a web request handler using the most popular web processing framework. It loads an order.
Szymon, I have a quick question. So Marko Markovic, he asked, is the message from the shopping cart to the shipping component an event or a command?
The ponies haven't decided yet. They will think about it later. It depends on, well, I won't get ahead of myself, but I will be talking about it in a couple of minutes, okay?
Okay, thanks.
About command event. So bear with me. So here's the how that sync-async boundary looks like in a web controller. We use a repository of some sort to find an order by its ID, and we call submit method, which means do some business logic required when the order is being submitted. Then we open a transaction of some sort, the transaction meaning atomic transaction that will either succeed or fail as a whole. And with that transaction, we save the changes that we done to the order, and here we publish an event, but don't get hung up to it. I'll discuss publishing event sending commands in a few minutes. But here we just publish order submitted event, and then the transaction is committed. So that's one atomic block that both stores that information and publishes a message. And now, well, Rarity, that's yet another pony. She's very pedantic about things, and she wants always to get things right, and looks for minor well, impurities in the design. So she tries to pick that design apart and asks how are you going to send a message and update DB in one transaction? That's usually something that, well, people sometimes take for granted. It shouldn't be taken for granted. And the answer that Twilight Sparkle had for that is just use a table to store messages. Just have a table that has 2 columns, a sequence number and the message body, and put that table in the same database as the shopping cart database. And then if you have that messages table in the same database as your shopping cart data, you can modify the shopping cart or the order and add a message to that table, and that will be sent. Then consume that message from that table, and to do so, you basically need a destructive select, which is available in most contemporary databases. A destructive select, that's T-SQL version, but it's for sure PostgreSQL supports similar concept. You select a top message from a table ordered by seek. So you want the oldest message that is in the table. You use update log to ensure that nobody steals that message while you're selecting it, because you want to get that message removed. And you use read paths so that if 2 threads are trying to access the same table and consume the same message, they would not actually end up consuming the same message, because one of them would be locked by one thread and the other would be locked by the other thread. So that read path means to SQL Server, take me the first not locked oldest item in that table, and then please delete it. And the output clause means send me the deleted data. Because it's within the transaction still, I can do some processing while that delete is not yet committed. And then the rainbow dash comes in again and says, oh, so you really did decide to build a poor ponies queue, right? So yeah, first time she noticed that the bad job was kind of queue implemented or queue in a disguise. Now what she really means is, yeah, it's a table in a database that works like a queue. We do have real queuing systems, right? Well, we do have real queuing systems, but most of the real queuing systems, they won't give you this guarantee that you can store a data and send a message within one atomic transaction. The notable exception is MSMQ, which is basically declared dead by now by Microsoft. So you can assume that you can't really use that approach. The answer is polyglot messaging, which basically means use multiple queuing system to achieve the overall goal of the application. So if your application needs to send messages, there might be different requirements for the consistency of this message processing in different parts of the application. And you can use multiple queuing systems inside that application to achieve those goals as all. You can have one blue queue on one side of the architecture or one side of the application, and a red queue on the other side, and they can have totally different characteristics. So for example, here, the blue queue, our database emulated poor ponies queue, is probably not that performant. It's slow throughput, but it's consistent with the data in a database. But we can handle it because that queue is only used by a small portion of the business process. Basically, it's used only for that one message, and the business process consists of dozens of messages. And then the red queue, that one doesn't give me this nice nice property about consistency with the data modification because I don't need it down the line. But what it gives me is really scalability. Think about RabbitMQ, for example, it can process thousands and tens of thousands of messages per second where I need it in the backend. In the front end, I really like this possibility of sending the message and modifying the data within one transaction. And then I can combine them with some sort of a router, that the network symbol for the router. So I get one message from one queue, I hand it over to something, some magic box or a magic circle, and that magic circle puts a message into a different queuing system. And there are at least two implementations of that pattern that I noticed. One is an service bus router, which I built out of being bored in the evenings, and then a more production-ready one, I would say, or much more mature one is Cupid Dispatch. They have a different design choices and slightly different niches, but they achieve a similar thing. They are able to take message from one queuing system and stick it into a different queuing system that has different characteristics that you need in that part of the system. Okay, that's basically how the implementation of the shopping cart is done in that system. So the ponies were quite happy with that part, and they decided to move on and try to design the second part of the system, which is preparing the shipment and actually billing the customer, because we want to make money and actually deliver value to our customers. For that part, the ponies discovered age-old book, Domain-Driven Design, by Eric Evans, and they decided to read it from beginning to end. And actually,
Szymon, sorry.
Yeah.
There is a quick question. There's from Jose. He asked if it's Cupid or Cupid, and what kind of messages does this deliver?
Okay, so I think it's Cupid. Not sure. I can get back to it later.
I will add the link to the comment section.
Okay, thanks, Daniel. So the idea about this Cupid dispatch is that it works with AMQP 1.0 protocol. So this router can deal with multiple endpoints, multiple messaging infrastructures that talk AMQP 1.0. So you can talk directly to Cupid dispatch, or you can make Cupid dispatch take messages from one infrastructure and put it to the other. As an example, you can install AMQP 1.0 plugin to RabbitMQ and make RabbitMQ talk AMQP 1.0. And another implementation that is quite popular is Azure Service Bus. And then you can use Cupid dispatch to move messages around using very elaborate topologies between these. And Service Bus router is C# and is based on Service Bus, achieves similar goal, but on a different layer. So while Cupid dispatch standardizes on the wire protocol, which is AMQP 1.0, the Service Bus router standardizes on Service Bus transports, which is not a wire protocol, but the API that Service Bus uses. But so the effect is the same. You can move a message from one queuing system to the other. Okay. Back to domain-driven design. So domain-driven design is a software methodology created and that has that book also, and the methodology has two sides of it: a tactical side and a strategic side. The tactical side is about how you actually structure the code and build a system that is aligned with business structure of a company. And the second part is more about figuring out what the purpose of the company is and where is the actual business value for a particular business. So here for this part, the pony is focused on the first tactical part, how to build a system in such a way that it's open for modification and well structured. And the major message that they got from this book is that aggregates and entities are the things that encapsulate behavior and data. So the idea is to structure the system not as a set of transaction scripts that modify data in certain tables in a database, but rather partition the system into a set of aggregates which combine both behavior and data. And those aggregates are defined in your favorite programming language like C# or Java. And data is, of course, stored in some sort of a database, but the database is just a stupid data storage in that methodology. The smarts are in those aggregates in C#, and they combine both data and behavior, and they encapsulate the data and the behavior. So nothing can modify the data from outside of an aggregate. And ideally, the aggregate doesn't give away any information about its internal state, or at least no information that can be used by a business logic. It's sort of okay to query the data tables behind the aggregate to show data on the UI, but not really to take any business action. For this part, of course, Rarity was the pony to design that part of the system, because she's really into designing a clear, pure solutions that are modeled according to well thought out rules. And she looked at the system from the lens of distributed business processes. What does it mean? Well, if you look at what the system for delivering pierogi needs to achieve is, you have some sort of shopping cart, and that shopping cart stores those items that the user clicked and ordered. And then there is a shipping, there is billing, and there is a whole process from that takes the information from the user as a represented as a shopping cart, and ends further down the line in actual package delivered to the customer of our application, of our system. And in the meantime, those steps are actually are part of the same business process, but they are handled by different components that communicate through messaging asynchronously. So the shopping cart does its part, sends a message to the queue, shipping picks up that message, modifies the data, sends another message, billing picks up that message, does something, and so on. And there can be many of these components. So that's a distributed business process. It's distributed because it involves multiple components, and each of those components has its own data store that it uses and doesn't share the data with any other component.
Szymon, I have a quick question from Jose again. So he asks, so the aggregate, is this like a microservice or a minor entity that composes a microservice?
So the aggregate here is part of the microservice. So we can think about those components like shopping cart and shipping as microservices, and within those microservices are our aggregates. And one of it's, at least for the ponies, it was okay to have a couple of different types of aggregates in each of those microservices, but it's not uncommon to see one aggregate. So for example, in a shopping cart microservice, there would be aggregate of type order. So each order would be represented as aggregate of type order and stored in a database. Maybe there are other aggregates there in a shopping cart microservice, but I'm not sure. In the shipping aggregate, the shipping microservice, the main aggregate used in that microservice would be shipment. Maybe there are other aggregates like representing types of packages or things like that. But generally, there is a small number of aggregate types in each microservice. And the aggregate type is just a C# class that defines the data and the behavior. So here, as I mentioned, the main one in the shopping cart is order. The main one in shipping is shipment. And well, if you zoom in into the shipping microservice or shipping component, it takes the messages from that queue, modifies the data, puts a message into another queue. It looks really simple, at least from that perspective. But now the question is that was asked before, well, command or an event. Messages come in multiple types. The most popular ones are commands and events. There are systems that are based on document messaging, which are a bit more esoteric, but most of the systems I've seen in the wild use either commands or events or both. And then the ponies had really a big dilemma because they didn't quite know what kind of messages to use. The Blue Book was no help for them because it's over 10 years old, and when it was originally written, the messaging systems weren't really that popular at all. So there was no reference to messaging systems in the Blue Book or using messages for that purpose. So they really didn't know. Because, well, they were fortunate enough that Rainbow Dash is kind of quick to pick something. She's really like the fastest pony there is. So she just wanted to act, to do something. So she was like, let's try commands. Like, what can go wrong? Let's try commands and we'll see where we can get with commands. So the design was following, proposed by her. We get a command to our microservice, shipping microservice. We process that command, we modify the data, obviously, and we send another command, another queue, and the next service in the chain, that's microservice, let's say the billing microservice, will pick up that command and do its job. How would that look like? Here's a pseudocode. Well, it's C#, sort of C#. I'm not sure if it compiles. That shows a class that handles messages. You know that it handles messages because it implements interface that shows it. It handles messages of confirm payment. Confirm payment is a command because it's in the imperative mode, right? So confirm payment message, I get the method for handling those messages is called handle because, well, and then we get a message and some sort of context that allows us to interact with the underlying framework of framework for messaging. So we take an order from a repository, we call our business method on an aggregate. Order is the aggregate here. And we call that confirm payment method, and whatever needs to be done while confirming the payment is the implementation detail of the aggregate. Aggregate should prevent anybody else from looking into what's happening there. That's the encapsulation principle of aggregate. And then last thing is we want to publish a prepare shipment command. That's a typo on my side. That should be sent because commands are sent, not published. So that should be context.send new prepare shipment because we want to get that message to the next component, which will handle that command. And again, Rarity is really good in picking up inconsistencies in the design. So she asks, how does your app service know what message to send? Well, if we look at the more elaborate example of that code, here's the problem that Rarity is pointing at. We have the order aggregate and we confirm payment, but the result of confirming the payment might be success or failure, or maybe some other state in between. There are multiple results possible here. And here, for the simplicity reason, I assume that there might be either failure or success. So if we confirm payment, then we publish prepare statement, or sorry, send because it's a command. Otherwise, we send the cancel shipment command. So if we manage to secure the funding for the order, we prepare the shipment, otherwise we cancel. Well, looks okay, sort of, in code, but then you ruined my encapsulation. The whole idea of the aggregates was to encapsulate all the logic required to perform a business action or a business step. And now we have that logic scattered between our aggregate and our message handler. And Rarity is not really happy about that. But here's the Pinkie Pie. She's really helpful pony. And she dug up a blog post that is more than 10 years old, a really like content that is from the Stone Age of software by Udita Han about domain events. Well, nobody remembers domain events anymore, but they were a thing back then. And I tried to kind of make them relevant today by using a more modern syntax for you, more concise syntax to explain what domain events used to be. So here's the same functionality, but structured in a different way that Pinkie Pie was at least hoped to satisfy Rarity in her desire to make things poor. We get an order aggregate, and then we use in-memory subscription of sorts. We are subscribing to a payment confirmed event locally in memory, and as a result of that event, or to react on that event, we'll publish prepare shipment command. Sorry for that publish again. And if we subscribe to a payment refused event, and then we send the cancel shipment command, and then we call that confirm payment. What confirm payment will do is, will again in memory, it will use in-memory message bus to publish either payment confirmed or payment refused events, which will result in us sending that command out here or there. But, well, rarity is hard to satisfy when it comes to really poor design, and she didn't like that either. It's sort of better because confirm payment doesn't return anything, so it's more encapsulated. But on the other hand, you can claim that now the communication between the aggregate, between the confirm payment method of the aggregate and the outer layer, which is this message handler, is really bizarre and obscure, and we didn't make things more readable. We just hidden the fact that the confirm payment needs to somehow return that information about the result of the confirmation. Fortunately, Twilight Sparkle is the kind of pony that reads a lot. Like, she has a huge library and she reads books and papers, and even papers in our industry. No, nobody reads papers in IT, right? But she does. And she really liked the Pat Hallam's paper about distributed transactions, or actually life beyond distributed transaction. If you don't know Pat Hallam, he's the guy that implemented a couple of distributed transaction systems. And then he declared that distributed transactions are not really worth looking at. And he, I guess, dedicated part of his career to try to convince people that they shouldn't use distributed transactions. And that paper is really really interesting from that perspective, that he declared distributed transactions obsolete. And one of the headings in that paper, again, is messages are addressed to entities. And by entities, Pat Hallam doesn't mean the entities in the sense of domain-driven design, where entities are small portions of the aggregate. Entities to Pat Hallam are sort of aggregates in domain-driven design. So here's that gap between what Pat Hallam wrote in the paper and domain-driven design. If you didn't read the paper and book, if you take them, those two things together and try to read them, make this mental connection, domain-driven design aggregates are sort of entities for Pat Hallam. And those entities, well, they can come into two flavors. You can get an aggregate, a real domain-driven design aggregate, that can take a command as an input and generate an event. And for duality, to make sure that we can actually build those distributed business processes, we need a way to take an event and turn it into command, because, well, with aggregate only, we would be able to build only one step of a business process, and that would be it. So a process manager, or a saga, but I don't want to use that name because that would create a Twitter storm. So a process manager is a kind of dual thing to an aggregate, because it takes an event and makes it a command. Why is it essential? So the main problem with the design that we had previously was that the aggregate was leaking the information about the result of the processing to some sort of outer layer message handler, so that that message handler can send a message. Well, in this approach, the aggregate can publish an event and as a result of processing the command. And because the aggregate is only publishing an event which states what happened, that aggregate doesn't really have a dependency on the further business process. It just says, that happens, deal with it. So it's focused on taking input and then declaring what happens. And then the process manager is kind of opposite. It takes that what happened and turns it into command. It doesn't have any state, any persistent state as a business entity. It only has a process state. So it knows where in the, for example, where in the ordering process I am, so that I can coordinate the messaging, but it doesn't know the order details, a list of items in the order, and so on. That information doesn't. Yep.
I have a question from Mark. He asks, is a process manager also known as policy?
A policy would be something different that I haven't covered in that presentation, although I was thinking about it today. So a policy would be probably yet another thing that qualifies as entity for in the Pat Helland's paper, because the policy would, I think, take an event, maybe generate a command or an event. I'm not really sure. I would have to think about it. But yeah, a policy would be a third type, I think, a more something that has a state specific to a policy, not to an entity. Yeah, that's a really good question. I need to think about that, how to bring that in. But for now, we'll just use aggregates and process managers. And if we try to structure our business processes, distributed business processes, in that aggregate process manager kind of way, here's what it comes. We have a payment, and that's an aggregate. It processes, or it handles a command confirm payment, and it does the business logic. So it changes the state. Let's say all the business state it does is this confirmed flag set to true, but surely the payment aggregate would have more state. And then it publishes a message, an event payment confirmed. And that event is routed to an order process, which handles many types of events. But here it just, what I want to show you is that payment confirmed is handled by that order process. And the state that the order process maintains, that payment confirmed is set to true. It needs to know where in the process I am so that I can prepare a shipment, but it doesn't need to know all the details of the payment and what credit card was used and whatnot. It would take an event, payment confirmed, and sends out the command prepare shipment. And then there is another aggregate, possibly in another microservice, but not necessarily. It can live in the same microservice. That takes the prepare shipment command, modifies its business logic, publishes another event. Those process managers or sagas, there are at least two known to me ways of implementing them or associate or kind of owning them. One school of thought says that those process managers live outside of microservices and glue the microservices. I can see how that might work. I'm not a big, I wouldn't endorse that kind of school of thought, but I know that it's there and people are successful using it. The one that I would endorse is that process managers live inside those microservices and more likely on the boundary. So here that order process would probably live in the same microservice as the shipment, because it sends a command to a shipment aggregate. So it would listen to events published by some other microservice and send commands to within that microservice. That, I think personally, that approach is better in ensuring the autonomy of services. But I've seen people use it, like I've seen people promoting those process managers to a top level concepts outside of services and still doing good in building software. But then it looks good on paper, right? Especially if you can show the code that is in static. Fluttershy has really this habit of digging into the details of the behavior of stuff, how stuff works, and finding holes in it. So she asked, what happens if you get a duplicate message? Oh, well, that's a really good question, because you remember I mentioned this polyglot messaging, and I mentioned this poor man's transport using SQL Server table that we use on the UI side of things, on the synchronous side of things. On the async side of things, we promised to use a real message broker. And a real message broker, unfortunately, means that the message might be delivered multiple times and we will have to deal with duplicate messages. As I mentioned, no other message broker apart from MSMQ can handle exactly once message processing automatically. So we have to deal with the duplicate messages somehow in our code. Doesn't mean it has to be the business code. It can be the infrastructure code, but it has to run in our business process. And here, again, Twilight Sparkle, she's good in reading stuff, looking for stuff on the web, and actually getting into how things work. And she found this pattern of outbox. The outbox is really a pattern that combines two concepts. One is, how do I send a message and modify the data in my database atomically? And the answer to that is, you don't send the message to a queue and modify the data. You store the message and the data modification in a database, and then you get that message stored from a database and send it to the queue. That ensures that in one transaction, I store the messages and the state change, and then send out messages. There is nothing that will prevent me from taking the messages from a database and sending them out. So I can be sure if I store them, I can send them out. That's fine. But the second part to outbox is, how do I ensure that I actually do it only once? Because if I can get duplicates, I don't want to modify my state multiple times and send out those messages multiple times. And here the answer is, if you store those outgoing messages in your database, you can as well associate them with the incoming message that triggered the state change. So apart from your data, what you're storing is a sort of dictionary that maps incoming message to a list of outgoing messages. If in that dictionary you have already the ID of the message that you are currently processing, that means that you already processed that message. But let's look at the actual code sample, how it works. And as I promised, it wants the implementation of the outbox pattern doesn't really doesn't imply you need to change your business code. We'll make sure that our message handlers, our aggregates and process managers stay exactly the same. We'll just wrap them around with a code that ensures that messages are processed exactly once using the outbox pattern. So first, we need to load our entity. Entity in Pat Helland's sense means a process manager or an aggregate to us by its ID, because, well, messages are sent to entities. And then that entity contains this outbox state, that dictionary. So we can check in that outbox state if it contains our incoming message ID. Let's say that's the first message, so it doesn't contain any state related to that message. So we execute the business logic, we handle the message, and that means we modify the in-memory state of our entity, and we also collect all the outgoing messages in that dictionary. And then we save the entity to the database alongside with the outgoing messages that the processing generated. Now we take out the messages generated by our most recent operation. So we go outbox of the message ID currently processed, and we look at it. Well, that's a list of messages that is outgoing, so it's surely not null. So we take them and we hand it over to the queue. Hey queue, please send those messages to their destinations. And then we mark this entry in our dictionary as null. What does it mean? It means that we sent out those messages successfully, and we don't need to resend them if we get to process that message again. Last thing, we try to save that state, meaning that the change that we nulled the outbox state. But suppose we failed here, like somebody took a plug out of the wall, server is down. What happens? Well, we have a proper messaging system, so the message is not gone. The message goes back to the queue and will be processed again shortly whenever the power is back on. What happens to the data? Well, we don't lose the data. Our most recent save point of the data is here, line 5, because we failed in line 12. We didn't complete line 12. So we're back to what we saved in line 5, which is we saved the modified state of our entity, and we saved all the outgoing messages in our outbox state. So when we are back to line 1, we load the state, we check if the outbox contains the message ID. Yes, it does, because we already processed that message and stored that state. So we immediately jump to line 7 and we get that state from the outbox and say, oh, is it null? No, it's not null. It's a list of outgoing messages. So let's dispatch them and send them to our queue. And that's what we do. Now we nullify that list to make a note to our future selves that we already sent those messages. and we try to save the new state. And this time we succeed. Yeah, nobody took the plug out of the wall, but something happened. The cosmic bit flip happened, and we failed line 13, which is just a moment before we acknowledge processing of the incoming message. So we're just about to tell the message broker that we're using, hey, I processed that message, and we fail. So what the broker does, it waits. It waits on a TCP connection, waits for a while, and eventually it gives up. If it didn't hear from us that we acknowledge that message, the message goes back to the queue and is redelivered. How about the state? Well, the last save point we went through is line 12. So we saved the state where the outbox dictionary contains the entry for message ID of our message ID, but that entry is null. So there is no list of outgoing messages anymore because we know that we dispatched them. There is null there. That null tells us that we processed the message and sent out outgoing messages. So when we get the incoming message again, load the entity state. Now we have that information in the outbox and it's null. So we skip line 8, and we get back to 13 and we acknowledge the processing of incoming message. So finally, we managed to ensure that we send out outgoing messages only if we process the incoming message, and that we process the incoming message only once. The only slight disadvantage is that our outbox dictionary, it will grow over time. So we need to figure out a way to actually somehow remove old entries from the outbox. So probably need to some sort of date time in that outbox, but that's an implementation detail. So yeah, outbox is a solution to the duplication problem inside our system, where we use those distributed business processes between aggregates and entities and process managers. And now the last part, it seemed to be the easy part, at least for the ponies initially. Just we need to generate the invoice document. We have all the business process covered. We just need that one last piece of paper to be generated so that customers can generate the invoice. And for that part, Rainbow Dash was the pony of choice to design that part. She's really like quick to design stuff, quick to experiment, and sometimes, unfortunately, she overlooks stuff. But she really likes simplicity, and she wanted to experiment a bit. She first tried to use the outbox, but she could not use the outbox, as it really requires your store to be able to store the outbox state. If you want to generate a store an invoice, the best thing you can do is store it in some sort of a blob storage or S3 bucket as a PDF document. You cannot associate the outbox state with a PDF document. There's no way to do that. So she had to figure out some clever way to implement deduplication of messages. And here's the way she came up with. So she checks if the invoice exists. So she tries to find an invoice by invoice ID. If it doesn't exist, then we generate the invoice and we store it in our S3 bucket or blob storage. And then we send a reply to the process manager that called our message handler, hey, process manager, invoice has been generated, I'm fine. And if that message gets duplicated for some reason, then we just check invoice exists. Yeah, it is there. We just log duplicate. That's it. We don't care. Well, we care because we log, but we don't do anything. So here's another example, what we can do. It's the first time we run the invoice. We're doing some tests in our acceptance testing environment, and we noticed that there are some replies missing. Some of those business processes are hanging without that invoice generated reply process. And when looking at code, doesn't seem like that reply can be omitted in any scenario. So they are trying to figure out what can go wrong. Here's one of the paths that they were investigating. So we store the inbox, we try to reply with invoice generated, and we simulated a failure in the broker. So let's build a chaos monkey type of thing that will ensure that in our testing environment, we fail to send that reply. So what happens? Well, the message goes back into the queue. We get the generate invoice command again. If we check if invoice exists. Oh, well, it does exist. That's a duplicate. Well, not really. It wasn't a duplicate. It was just a failure to generate, to send a message. So here's again Fluttershy. She's shy, but she's really smart. You can't distinguish a duplicate from a retry after a failed publish. That's really wise words. Looking at state in a database, a message that has been duplicated looks exactly the same as the same single message that failed to publish outgoing messages when it was processed the first time. The state in the database is already modified. We don't know. Well, if we don't know, we need to stay on a safe side. We cannot just throw messages out there. Well, not at least not in that system. So we need to make sure that that reply gets back to that business process, that process manager that waits that reply, because the business process will be stuck otherwise. So the change that is required here is very small. We need to move that context.reply out of that code block here. So if that invoice doesn't exist, we store it and then send a reply. But if it doesn't exist, we store and reply. But if it does exist, it might mean it's a duplicate, but we're not sure. So we stay on a safe side. We log that message and we send the reply again. It doesn't cost us anything. In case it was a duplicate, the process manager will get a duplicate invoice generated reply, and it will deal with that duplicate because it's smart and it can deal with things like that. But that's the only way we can ensure that the reply actually gets to that process manager. And well, as I mentioned, she's really quick to experiment and likes to get things really simple. So what she says is, see Twilight Sparkle, told you it can be simpler than your Outbox. Yeah, Outbox does look a bit complex if you look at it for the first time. So Rainbow Dash wanted to make it simpler. And she made it simpler and shipped it. And well, it didn't work that well. So they started investigating again, looking at what could happen. And they found a scenario. Here's a slightly different code that they shipped after shipping the first version of the system. And the difference here is that there is a new event in that version of the system called first item added. So whenever there is first item added to the order, we publish the special event first item added because the marketing guys, they want to know when the first item is added to the order. So how much time does the user spend between creating a brand new order and adding the first item? For some reason, that's marketing gold for them. So here's the handler as it looks like after Rainbow Dash simplified it. We load the order and let's looking at in the debugger, it's order ID 123, and we check if we already processed that order. We didn't. So we add an item to that order and we store that order in the database. So far, so good. Then we check if number of items is equal to 1. And yes, it is equal to 1 because we just added the first item. So we want to publish the first item added event. But well, for some unfortunate reason, we fail here. But, well, nothing is lost, right? The message goes back to the queue and we'll process it later. But in the meantime, the user clicked again on the UI. And there is another, that order ID is the same, but the message ID should be different. So that another message came in for the same order, but the message ID is 234. So we haven't processed that message yet. So we add another item to that order. So now the order has 2 items in it, one added by message 123 and the other added by message 234. We check that condition here. No, it's 2, it's not 1, so we don't publish first item added. And now we're getting back to the original message with ID 123. We check if we process that message, and yes, we did process that message. Oh, that's cool. And now, because we want to be on the safe side, we want to execute our message sending logic to send out all the messages that we need to send out. But here, that message sending logic now is slightly different. It's not unconditional message sending logic that like we've seen before with the reply in our invoice generating message handler. it's actually conditioned on the count of items. And that count is now 2 because there are 2 items in a database. So we don't publish the first item added. That message goes back, goes to the trash can, and the marketing people, they are really upset because they don't have the data that they were really looking for. Well, of course, Twilight Sparkle has an answer to it. You need to make all side effects idempotent, not only the state change. And here's what you expect to get when you ask Twitter about exactly one's processing or exactly one's delivery. The Twitter tell you just make your business logic idempotent. Well, not really. What you need to make idempotent is not the business logic, but all the side effects. And for majority of message handlers, all side effects involves the business change, the data change in a business database, and the messages that are sent out. In most business scenarios that are not non-trivial, the messages that you're sending out not only depend on the incoming message, but also on the state of a database. And to make that idempotent, you basically need outbox. That's the shortest answer. Otherwise, you would have to store the state historically for each message you process, but that's not really realistic. So yeah, you need to make things idempotent, but not only the business operation or the business data change, but also outgoing messages, which means outbox. But in case you have really simple example, like the one that's Rainbow Dash worked with initially, there's this pattern called message sync. And that pattern relies on the natural idempotence of certain operations. So if you are storing an invoice document in a blob store, that operation is idempotent. The number, well, you can store it again and again and again, and assuming that invoice is generated based on the same data, it will look the same even if you regenerate it 1,000 times. So if you have this message handler that relies on the natural idempotence of operation, like generating a document, for example, and then all the outgoing messages are derived from the incoming message. So as we've seen with the reply, if the only outgoing message is a reply, yep, I done it, then the outgoing message is purely derived from the incoming message. It's not based on the data that was in any sort of data store. If you do have those two things, those two conditions, then message sync is a pattern for you. The way that Rainbow Dash implemented the storage of the invoice documents, it's actually the easiest way it can be done. And it's, in some cases, the only way it can be done. If you're dealing with a data store that stores images, you can't really implement the outbox on top of it because, well, you can't add outbox to an image. So that's the only thing you can do. But the problem with that, well, the trade-off here is that the message sync endpoint or message sync handler cannot move the business process further. The only thing you can return is a simple message that states what happened, or if it failed, that can state that it succeeded, basically. So you cannot go back from a message sync. That's why it's called sync. And to make it more apparent, the whole idea, the whole approach to architecture that the ponies eventually created, they wanted to draw a single diagram that would summarize everything that we talked so far about message syncs as business processes and aggregates and process managers and the sync-async boundary. And that's basically this diagram. It's not the architecture diagram, I would like to underline. The architecture diagram shows the architecture of a concrete system. So it shows the components of your system on a diagram. That's the diagram of a set of architectural patterns, because it's agnostic to a system. It doesn't show what the system does. It doesn't show what those components do. It just shows like placeholders of components. So it's sort of a framework for a proper architectural diagram that you can draw. Let's start on the left-hand side. There's a user interface, and that user interface in a browser, you click something, there is an action that is done in the input layer of that system. So it has 3 layers. The input layer is the one that communicates synchronously with the user, responds to users' clicks here and there, and has its own database, of course. When the user is happy with the data that they provided to the system, they click one big submit button, And that big submit button means that there is an async communication between the input layer and the core layer. So a message is sent. I remember that SQL transport, a poor man's SQL transport, a message is sent to the core. And the core consists of aggregates and process managers that communicate together and form those long chains of distributed business processes. They are the meat of the system where the business logic is executed. The policies, if we had policies in the system, would live also in the core. And the messaging here can go in many different directions because, well, you can have circles and whatever patterns of message routing here in the core. But then sometimes you need to do some sort of communication with the outside world, like generate the PDF document or send out a request to a payment gateway or store something somewhere called an API. For that, we have the output layer. The output layer doesn't have its own database, as you can see. So the message that go from the core to the output layer, they cannot push the business process forward. It's sort of one-way thing. If you get a message from the core to the output, you do something, you interact with an external thing, but only the component that lives in the core can push that business process further. So it's that the output layer is the layer for the message sinks. They live there. They have this simplified idempotency-based deduplication mechanism that Rainbow Dash design. The core is the place where there is your domain logic and business logic and the aggregates and Blue Book and Rarity lives there. So that's the summary of the whole system. And last thing before we end, I would like to underline that what we covered today in the last, well, almost 90 minutes is not the architecture, it's part of the architecture. I would call it it's the one view of the architecture that is involved in message processing. So how you process messages, how you deduplicate messages, what are the message routing patterns in different parts of the system, where is the boundary between sync and async messages and so on. That's the message processing layer of the architecture of your system, but there is more, much more into it. You have the communication infrastructure as part of the architecture, which means what are the communication mechanisms that you use? For example, HTTP there, Azure Service Bus here, MSMQ in that part of the system, and how you connect those pieces of infrastructure together. So that Cupid dispatch, where does it live, and how does it move your messages from Rabbit to Azure Service Bus? That's another view of the architecture. Then we have the problem space that the Blue Book is really concerned about, the domain-driven design book. So how to partition your domain into subdomains, and what kind of attributes you attach to those subdomains, what subdomains are more important than the other. There's logical architecture, which means how do you partition your solution space. So how do you partition your system into microservices, picoservices, nanoservices? And there is some evidence that the alignment between problem space partitioning and logical partitioning is desirable in your architecture, but I know systems that don't follow it. So yes, it's sort of similar, but I would like to underline that there is a difference. And in domain-driven design, the bounded context, for example, is a problem space term, not a solution space thing. So if you see people that talk about bounded context in a call bounded context is equal to microservice, it's not. Bounded context is a problem space. Think microservice is your solution space or your logical architecture. And last but not least, you need to have your Kubernetes showed somewhere, because you need to show off that you know Kubernetes. All of us need to do that, or at least all of us who call ourselves architects. So you need to deployment perspective on your architecture, where your functions, Kubernetes, and that kind of thing live. So what I touched is just 1/5 of the big picture, but I hope you enjoy it. If you did, here's my blog. It's exactly once GitHub.io that I run with my colleague Tomek. and we write about things related to message processing in distributed systems, especially focus on deduplication of messages. And then I'm not sure if it would, it's a small shameless plug, I'm not sure if that conference would happen. I would love to be there. It's still scheduled in May in Copenhagen. We'll be running with Tomek a workshop on consistent messaging in the cloud, meaning how to process messages in a consistent way and send messages between microservices. If it does happen, I really would like to invite you. If not, probably there will be an online event for that. And with that, thank you. Here's a bunch of links how to contact me. I know that Daniel already posted my Twitter account. There's LinkedIn account and GitHub. So thanks for joining me.
So Szymon, we have one question. So Bruno asked it. It is roughly 15 minutes ago. I'm not entirely sure to which slide it was. So we might need to reconstruct that. But he said looks to me like a lot of performance optimization. So should the takeaway be distributed system need performance optimization in handling at least once messages unless they shall fail miserably? And then he added a smiley to it. So I wasn't sure if it was tongue in cheek, but he asked me if I should, if I can ask it at the end of your presentation.
Yeah, definitely. There is a lot of performance optimization that needs to happen. And some of the patterns that I showed, like the outbox pattern, is that the version that I showed is really simplified. And the way that poor ponies transport based on SQL database works with the delete statement that returns data, it's also a very simplified version. And the actual implementation of how you send messages through a SQL database can can make it either 100 messages a second system or a couple of thousand messages a second per system. So yeah, that there's a lot of places to optimize there, and yeah, that's probably harder than a system that is not distributed. I would agree. Like keep in mind the first law of distribution. I know that Martin Fowler, when he formalized that law, he was talking about distributed objects, but it applies to any kind of distributed system. Don't distribute. But on the other hand, my pragmatic approach is that we sort of are forced to build systems in the cloud, and everything that we build in the cloud is distributed by definition. So it's, yeah, it would be nice to get back to this nice comfy place where things were not distributed. Not really when you're dealing with the cloud.
Okay, so any more questions to Szymon? Going once, going twice. If not, I'll give you a little bit more chance to ask questions in the chat or in the Q&A section while I make a small introduction to the next event. So we have another online event. It's going to happen on the 7th of April. It's called From Zero to Hero with Several Years of Anguish. So we invited, in a collaboration with the .NET User Group Bern and also the HL Breakfast, we invited Debbie O'Brien to talk about her basically experience and knowledge in the developer space, because she was not working, she's a woman now in the tech industry, and she was previously not working in the tech industry. And she joined the tech industry and talks about all the things she learned going from zero to hero with several years of anguish. And I think it's going to be a great outside perspective onto our profession. And I strongly encourage everyone to join us for this next online event. We will be using the same tool, the webinar. Yes, I could show the meetup site. Thanks, thanks, Jose. Let me see. I can also quickly share my screen, but here we go. Hopefully you can see that. This is the next event, so feel free to subscribe there. Of course, we have almost unlimited seats, so you can also publish this event on Twitter, wherever you like, and hopefully we see a lot of people coming on that next event. And I would also like to tell you that we really are grateful that even though this is a virtual event, and a lot of times virtual events actually have bigger no-show rates than like the physical ones, and we are really grateful that people that committed to coming are actually coming to this event, because we want to keep basically the spirit of the .NET user groups or the user groups going even in this difficult time. Thank you very much for everyone for coming, and I wish you a great evening, and most importantly, make sure you stay safe with your friends, beloved ones, and your families. Thank you very much. Have a great evening.